Welcome back to this video. In this lesson, I'd like to run through a couple of examples where we divide surds, as you can see here written down on my left. And let's just assume I was told to simplify the following examples. And I hope you were with us in the previous video where we formulated the second fundamental property when computing surds. It went a little like this. If you had the root of a divided by the root of b, wait, hold on, that looks like a 9. I want to take it out. Yeah, if we had the root of a divided by the square root of b, this is the equivalent of big square root a over b. It's the same thing, right? So for the sake of this video, let's run through a couple of examples, and using this formula up here, you can keep referring to it, and so we can say that the idea becomes more familiarized with ourselves, and at least we can say we conceptualize it better. So let's take a look at our first example. We got the square root of 10 over the square root of 2. And look at this. If we assume square root of 10 is the square root of a, and the square root of 2 is the square root of b, then we can simply boil this down to simply square root of 10 over 2, right? But I don't want to stop there. I know 10 over 2 can be simplified even further lower to 5, right? So instead of writing 10 over 2, I can just write this as the square root of 5. And as you can see, this is a lot simpler and a lot shorter, and a lot easier looking than this square root of 10 over square root of 2. And it's really helpful and handy to have surds simplified when you're working with calculations, right? So just like when you're working with fractions, you want fractions in the simplest way. You'd also want surds in their simplest expression. Let's try this other one. We have square root of 20 over the square root of 10. And look back here at our equation, we can assume square root of 20 is square root of a, and square root of 10 is square root of b. So what would this imply? This would simply imply, take this big square root, right, of 20 over 10, right? 20 over 10. 20 over 10. And just like in the example we just solved, 20 over 10 can be simplified even lower to 2, right? 20 over 10 is simply 2. So I can just rewrite this whole mess here as the square root of 2 rather than 20 over 10. And again, this is a much simpler form than this little fella over here. Let's try the next example. And I hope you're at least getting a little hang of this. It might take some time, just practice. So we have square root of 1,000 over square root of 10. What do we do? Well, let me just scroll back so you can have a look at the formula. Just take the 1,000 over the 10, right? Square root of a or square root of b. Just take the 1,000 over the 10. That's all you have to do, right? Instead of having two separate square roots, just make this one big square root and leave the fraction as it is inside. So now 1,000 over 10 is 100, so you can write this as square root of 100. Now I know you might be tempted to just leave it as square root of 100, but remember this, 100 is a square number. It has a square root, which is a whole number, a real number, and that number is 10. 10 is the square root of 100, and I don't need to explain that, right? So instead of writing square root of 100, you might even simplify it further to simply just 10. And I think that's a lot simpler. I'm hoping you do too. Let's look at this one. This is the square root of 16. I want to make the 6 a little clearer. 16, I guess that shall do the trick. 16 over square root of 2. So again, same method. Just take one big square root outside, right? And you have 16 over 2. Well, look at this. Again, you can take this as 16 over 2 and write it as 8. And you can just have square root of 8. Square root of 8. Now, if you have the square root of 8, remember this. Let's think about what factors make up 8. Let's think about what factors make up 8. We have 1 and 8, right? And 2 and 4. 2 times 4 make 8, 1 times 8 make 8. But from these two sets of factors, which one has a number that's a square number? Well, it's the second one right here, because 4 is a square number, right? 4 has a square root, which is a whole number. So instead of writing this square root of 8, I can re-express this as the square root of 2 times 4. Square root of 2 times 4. And if you remember from the previous video, this is nothing really new. We can rewrite this as the square root of 2 times the square root of 4, if you remember your first fundamental property of surds. But remember, square root of 4 is simply 2. So you can write this as the square root of 2 times 2 separately, which basically is the 2 square root 2. Right? That's all it is. 2 square root 2. And this is a lot easier because, I mean, you always want a small figure under the square root, right? That's the simplest form you can possibly express it as. And you might probably be asking why we didn't do that over here. That's because over here, 5 is a prime number, 2 is a prime number. The only factors it has here are 1 and 5, none of which are square numbers. Here you have 1 and 2, none of which are square numbers. 10 already is as simple as it gets. Why would you want to express that as a surd, right? So that's what we did over here. Now let's try one more over here so we can at least completely say we get the hang of it. We understand what we're doing. Well, again, as always, just take a big square root. Well, we have square root of 54 over square root of 3. So we just take the big square root, and you'll have 54 over 3, which is 18. So you can have this as square root of 18. But, 18 is an even number, and then it's not a prime number, so it probably consists of factors. Hopefully, one set of which contains a square number. Let's think about it. What are the factors of 18? You have 1 and 18, 2 and 9, probably 3 and 6, right? This is what I can think of at the top of my head right now. Well, have a look at this. The set here that has a square number is this one, 2 and 9. 9 is a square number. Its square root is 3. So instead of writing square root of 18, right, I can just re-express this as the square root of 2 times 9. Square root of 2 times 9. Which, of course, is the same as square root of 2 times the square root of 9. Which, of course, is 3 square root 2. Now I know this process might seem a little long just to simplify a set of surds, but with practice it becomes really easy and at your fingertips. So I encourage you to just practice a couple of surd questions. You can get them from any textbook, any online source, and it becomes really handy and very familiar with you. So I hope you enjoyed this video. We'll cover some more examples and questions including surds. So I'll see you next time. Thank you.